Okay, so our final panel is the applications panel, and I suppose that's where data science rubber meets the road. We have, again, 3 panelists. Nicole Hemsoth, who's the Director of Editorial Operations and Managing Editor at HPC Wire. In the middle, Johannes Lietz, who is the Senior Manager of Data Services at the Gaussian Computer Center of the Max Planck Society. And on the far end, Thomas Zachariah, who is the Executive Vice President for Research and Development at the Qatar Foundation. Thank you all for coming. By now, you sort of know the drill. I'd like to get a brief statement from each of you and then do some discussion. My seed questions for the applications panel are, how does or how will data science change your field? If you want to look at a single field, but feel free to look at however many you like. What do you need to have this happen more effectively? Infrastructure, software tools, education, what are the bottlenecks? And then again, to sort of follow on the theme we developed in the last panel, what about social media, the Internet of Things, citizen science, all those things? Will there be applications for them? Or think new applications in general, if you like. So traditional applications and new ones that will spring up as data science grows. Opening statements, Nicole?
Okay, well, I'm not an end user, but I talk to lots of people in this community, in the HPC community, and also covering Datanami, people in the unwashed masses camp that you talked about before.
Subscriptions just are starting to get canceled now.
I think you made an interesting point, though, that and this doesn't really answer any of your questions either, but you were talking about a division between HPC audiences and the big data, kind of general data scientists. And they're 2 separate things. And you go to a big data event, like one of the events that's sort of the supercomputing of big data, for instance, and you talk about HPC, and people say, well, that's supercomputers, that has nothing to do with what we're doing. You come here and it's all big data, but they're starting to mesh to such a point that the tools, I think, there's going to be a lot more overlap. For instance, I just had a conversation with somebody about, on the big data side, general big data side, about Lustre, which I would have never imagined hearing about, really an HPC file system for a company that's using it for Web 2.0 stuff. So that's kind of one of the interesting trends that I've seen talking.
Well, that's a hopeful sign. Johannes?
I think we need to distinguish between what means field, distinguish between economic area and the scientific area. It's not always so clear. Big data is normally discussed, or very often discussed, in the economic area, and my view is coming from the scientific field, actually astronomy, plasma physics, but also the projects that I'm involved in during the establishment of a European collaborative data infrastructure now. There are many requirements and demands coming from astronomy, as well as the earth science and the plasma physics, the biodiversity science, and interestingly, the humanities. It was already mentioned about the long tail data, the data where the third V is involved with the variability, where data is very heterogeneous. And here the humanities play a very big role in demanding more resources, storage resources and capacities also to do their work. And they rely also on crowdsourcing, because they think that they have a lot of applications where field scientists, citizen scientists as well as academics in the field can collect data. And this data needs to be authenticated. The quality of the data needs to be in a certain state. And this makes a difference between the economy field and the science field. In the science, we need reliable data also when we talk about big data. It needs to be reliable and stable. And we think also we need not just transient, we are not talking about transient data here, we are talking also about long-term archive data. And there are applications and requirements in this direction, coming, for instance, from the domain of the cultural heritage people.
Thank you. Thomas?
So you asked the question, what are the challenges? I would talk about the application that you are focused on. So in many ways, I will summarize in my current role, the application that I'm focused on is nation building. So it's a much more broader field, but it has a very specific objective, very specific timeline. Because in Qatar, for example, many of the investments are tailored around a particular timeline, and for better or for worse, the country has decided that 2022, when the World Cup is being held in Qatar, that is going to be the coming out party for the country. So there is $140 billion of infrastructure investment that is being made in a country that is 6 square miles, in a city, in a country that is, say, 11,000 square kilometers. But most of the people, about 90% of the people, live in the city of Doha, which is 6 miles by 6 miles. And about 95% of the wealth, of the wealthiest country in the world, is in that 6 miles by 6 miles area. The reason why this is interesting is that all of us recognize that there is an urbanization trend going on in the world. More and more people are moving to the cities. We also know that the global population is going to peak, or it's estimated to peak at about 9 billion by around 2040 to 2050, that is the estimate. So we're going to add 3 billion more people in urbanized environment, which the estimation is that so the world is going to produce 1,500, 2 million-ish cities in the next 30 to 40 years. In many ways, what we are trying to do, what we are trying to accomplish in Doha, or my challenge is, it is a 2 million-ish city. We have the resources, it's not a resource-constrained world. So we have the ability to design a city, a New Deal, if you will, using, you use the word Internet of Things. It's really information driving urban planning, information driving new technology development. We've decided that we need a gigawatt of solar energy for meeting our obligations to FIFA in terms of a carbon neutral World Cup. We've decided that we're going to produce 40% of our food as opposed to 8% using the same land mass and same amount of water, which means it basically translates to recharging our aquifers to 1980 levels today or over the next 20 years. So it is driving a disparate set of challenges at the same time, all driving towards a highly interconnected, thinking of a city as an integrated system as opposed to sort of disparate planning. So mobility, autonomous driving, efficient buildings, all the things that we are able to plan. So to me, I think data is very, very important to drive that application. And then finally, you mentioned social sciences. In a country that is changing so rapidly, in a country where 15,000 foreign nationals are added to the country's rolls every month, where the citizen population is only 10 to 15% of the total population, the impact of all these change on the social dynamics of the country, all these things are really at the heart a data analysis problem. So it's an interesting place to be.
Mm-hmm. Thank you. Yeah, I mean, that sounds like a very interesting problem to me, because one would think a lot of the applications, data apps that would spring out of this would be new ones. And the problem seems large enough to be interesting, but it's bounded. So it should be solvable.
Because the population is is in some sense relatively small. We can think of what would otherwise be considered tremendously challenging problems. But so things like geotagging citizens or people who live in the country, having personalized medicine for everybody, because if you think in terms of it, 2 million people is a small fraction of 1/100th of U.S. population. So part of the reason also is trying to do things, thinking of the country as a prototype laboratory, a user facility for tackling problems that in big cities like Mumbai or Sao Paulo, or pick your big cities, you would not want to deploy some of these technologies right away in a very complex, messy city with existing infrastructure. Since we are building the infrastructure new, we have the ability to sort of use this as a lever to test out these new ideas.
Comments or other thoughts from our other panelists?
I'll say something. Like I said before, the worlds of HPC and big data are so separate, but the applications that you're talking about, I did a lot of research and covered a lot of these applications that are being created by teams of 2 and 3 people, not research labs, but they're not utilizing high performance systems. These are standard boxes. There's no acceleration. It's nothing like we're seeing here this week, but there's enough of an overlap in terms of just not even data size, but in maybe the scale of projects like this that I think is noteworthy. That's part of what brings HPC and big data together in some senses.
Thank you. Johannes?
For science, big data is not just a challenge, it's a big opportunity. Driven by the technologies which are now available, also in terms of these simple boxes which are now available to install in memory databases to work on unstructured data, and which allows also to make different projections and test different concepts. And this is for scientists a very big opportunity, not just a challenge. So I see in many fields where I'm more or less involved, which the Max Planck Society is working on, that these opportunities are taken up by using these technologies, starting with Hadoop. Certainly, this MapReduce Hadoop is one of the techniques. But also working on new generation of browsers to traverse through the data universe. And this is another point. Big data now, and together with the techniques that are available, the resources, the machines, the large shared memory machines, to a reasonable price. This allows us also to work on data observatories, to create observatories for data so that we can reuse and repurpose data much more easily than it was possible before. This increases also the significance of the results, because the recalibration can be done much more easier than it was possible before. And all these are really opportunities, not just challenges for science.
So your comments, all of your comments, make me wonder at least a couple of things. One of them is long-haul bandwidth going to be a problem? And the other one is more application-specific, and that is, if I think about the apps that I have on my phone now, I've got a couple on there where data is being collected about my local environment, and it's being sent to a central location where they're using it to try and improve weather forecast. Okay, there's been discussion of using the accelerometers in phones to create sort of a global ad hoc network of earthquake detectors. But so there, it's sort of one way, right? The phone is pushing data through an app up to somewhere else. But I'm wondering about the other end of things as well for the kind of apps that we're interested in. Will data applications evolve into something that so that they look more like what we call apps for phones and tablets, and in terms of usability by non-experts?
I hope I understood your question correctly, but to have
It was
those apps,
it was very convoluted. So
I hope those apps should be our goal, to make it easy to use by citizens, and so that citizens become scientists. But now again, I have here the scientist view. Of course, there are a lot of apps in the economic world which also allows to make money, and this is one of the great opportunities too.
So you had a premise, and the premise was that there was somewhere a human in the loop. It doesn't have to be. I mean, so again, if you some of the things that we are certainly considering is because clearly we are building a brand new city, and we have plans for dramatic amounts of sensors to where we hope that the system itself is optimized, whether it's traffic or whether it is efficiency and power and so on. So there is data science in a different set of dimension that is not just collecting data for a human being to analyze and then arrive at conclusions, where data science can itself drive behavior of a system. And if you think of a city or a country as a system, you can drive behavior. And not only that, there's also, I mean, some of the challenges that we have in Qatar is that in a country where incentives policy doesn't drive the right behavior, because you have a country where there's no tax, no power is not metered, water is not metered. So in a world, so Qatar is the highest among the highest light intensity. We lose 30% of our desalinated water somewhere between source and sink. And so there's lots of optimization that need to occur. And if we cannot rely on human beings to do that, then we have to let the system itself drive the behavior using data science. So there's lots of interesting things that you can do when you imagine things, when you redefine the problem slightly differently.
thank you. That reminds me of the other question I had, which is, so Thomas, you spoke of Doha as a sort of test bed, producing solutions for Qatar, but also ones that might be, let's say, portable or exportable or usable elsewhere in other cities. What's the view from, say, Europe and the United States? And since we have one panelist from each place, I guess it means you two. Are the kind of solutions Thomas is talking about, to me they seem necessary, but I wonder how easily they will be adopted in places that have very well-established infrastructure. How do you read the tea leaves in Europe and the States? Nicole, do you have comments?
Yeah, and we tend to get feedback from around the world, but in the United States, we'll use the United States in particular because it's a good contrast to what you're doing. But pretty much, I don't know what the exact figure is on how many mobile phones there are, smartphones, tablets. Having access to a wide range of applications that are feeding data to systems that can make life better or more convenient or more invasive to our privacy or what have you. That's easy here. The application ecosystem here is rich, and I think I kind of live between two worlds. On the big data side, I go to events and talk to people that are working on these types of applications, and there's so much happening there that never touches HPC, but that data can eventually, I think, be collated and put together to where it would be very useful for the study of large-scale systems, whether it's cities or climate or you name it. I mean, so there's cooperation between the general app development world, I think, and eventually, you know, large-scale research and national labs and such.
Thank you. Any thoughts, Johannes?
It's difficult to make a prognosis. We are in our cities in Europe very well developed in terms of the classical infrastructure. I think in parallel we will there will be a society level of society which will use these apps, and these apps will be the information will be provided for them, but there are enough of people who are not interested that much at the moment, and I think this will sustain for quite a while. So it's not easy to get new technologies through in the next 5 to 10 years, but there's a tendency, of course, to give it a push.
Okay. You know, somebody mentioned the privacy word, and that's maybe another issue. Actually, the question is it an issue, or to what extent is it an issue? Is it an issue that dies? If it's age related, does the problem go away when older people die? Younger people, I mean, the conventional wisdom seems to be that younger people are not as concerned about privacy issues as older ones. I'm not sure the problem is quite that simple, but people seem to be willing to trade privacy for some perceived advantage that they get. How does privacy intersect big data and big data applications? Is it an issue or not?
Well, I mean, I think it's a trade-off, without a doubt, and we are less private today than we were 100 years ago. You know, the sphere of influence and awareness and knowledge for my grandparents who were in the city that they were born and raised and never left the city. And so, you know, you can contract back down to a very safe zone, but I don't think that we are willing to trade all the upside that goes along with the services that you get. So it's a balance, and I think that there is there's a fundamental issue, but there's also a generational sensitivity. Like you said, the younger generation seems to be much more comfortable posting their pictures, etc., on the web, whereas older generation are not. Ultimately, I think that I think it's an irreversible trend. There's going to be more information about you that is out there, and if you are to engage the world that you live in, it is hard to avoid it. I mean, increasingly people are asking if you go shopping, they know information about you. So even when you are not consciously thinking about data privacy, it's not very private. That's probably what I would say, is that it's a challenge. It has to be a conscious decision, but the trend is moving to more data and therefore less privacy.
Yeah, I think personally I tend to agree with you, but we have just a minute or two left. If Johannes and Nicole would like to either comment on this or have any other thoughts to share, please.
I think
Johannes.
the privacy topic is an issue, and that's one of the reasons why new technologies which require geotagging, that you are logged in and so on, I have at least in Europe not touch or have some criticism, and also here I would discriminate between science. Those who want to help science and want to improve the data, they need to authenticate, because it's important to know from whom this scientific data came from. But in many other fields, I think here it is not directly necessary to leave all the geographic information and the personal information, and this is on the European agenda already. There are European rules, and they are much tougher than in other cultures and countries, and there's also a lot of criticism coming from the economy side and demands to relax these rules. But these rules say that no data needs to be collected, private information that not necessarily have to be used in the context of for which it was collected for.
I'll just, I think oh, there we go. I was talking to somebody today about the NSA data center fiasco, where people got really worried. Oh no, the NSA is collecting our data. And this person who's a researcher at one of the national labs said, the funny part about this is the more data that we collect, the safer we are. And you can obviously argue about that. But then he said, the more data we collect, the less you matter within that data. It's metadata. It's not personally identifiable data. It's all feeding into this structured and unstructured stream to yield these really big, large-scale results that are charts and graphs versus, centered in on people. And I wonder if this younger generation is kind of coming to terms with the fact that they, the government or whoever it is not watching them. This is all factoring into these large-scale trends that we can now identify, which could lead to a much better world in the end.
We hope so. I think we'll have to leave it there. This panel, as with the previous two, I think leaves us all with lots of food for thought. My personal thanks to the panel. Audience, if you would like to thank the panel, we'll wrap up the session.